Example 4, find a polar equation of your conic that's given below. Again, the focus is what? At the pole. Yes, that is exactly the same spot. Okay. You're given E equals 2/3. Your directrix is set parallel to the polar axis, and you are 3 units above the pole. So that means, is this a sine function or cosine function? Sine function, okay. We will start with the standard format, R equals E times P divided by 1. Because it's 3 units above, it would be a plus E sine of some angle. All we have to do is find E and P and we're good. Do we have both? Yeah. So E is 2/3. What's P? 3. Let's plug it in and then make it pretty. R equals 2/3 times 3 divided by 1 plus E is 2/3 times sine of some angle. We are going to reduce the 3's. So now we have R equals 2 divided by 1 plus 2/3 times sine of theta. You have to clear up all fractions in the polar format. So what are you going to do? Multiply what? 3 by all terms. 3 on the top, 3 on the bottom. So final polar equation is R equals, give it to me, what's on the numerator? 6 divided by 3 plus 2 sine of theta. And that's how we do it, baby. Okay. Last section. Parametric. Okay, so would you guys agree? You guys have been studying functions since you can remember how to do algebra. What grade was that? 8. Perfect. Now, recall from memory. In your own words, tell me what the definition of function. So fill it in your notes. Right or wrong, fill it in. Is it that terrible? So fill it in. Fill it in. What a function is. Don't wait for me because I'm not writing it. Once you have it, can you read it to a nearby friend to see if it makes sense?
I just said one value for x value.
I said an expression and write the output for an input. There's a multiple amount.
Since I'm not writing it, because you're writing in your own words, Alex, what's your definition of a function?
For every x value, there's only one y.
Every x value, there's only one y. That makes a lot of sense. Jacqueline, what is your definition?
I said it's like an equation that fits or passes the vertical line test, and like Alex said, there's only one y value for x value.
One y value for one x. Is that the same thing as what Alex said? Every x for one y?
Yeah. Wait, I said x value is y.
I just like said it, there's one y value for every x value, so I said the same thing, but I said it.
Oh, is it the same?
Yeah.
Yeah.
Those are the same thing.
Ah, guys, every x value for every y is not the same thing as for every y for every x.
That's not what it said for every x value, there's only one y.
Okay. Yeah, so for every x, there's only one y. Every y, there's only one x.
One y.
There is no Y.
Huh? What did you
Like I
say?
said, there's only one y value for every x value.
Yeah, it's the same thing.
No, you're right. No?
There's only one. I'm trying. Let me try to understand that English phrase here.
So let's say we have y equals x squared. So 2 squared is only 1, it's only 4. But 4, there's 2 x inputs.
Right.
2 is negative.
That's why I want to make sure that sentence is correctly.
Can we just say it passes the vertical line?
Yeah,
first?
so the correct way to say that is like Alex, and now I'm questioning what Jacqueline said. I'm gonna ask you to say it one more time so that way I can understand. So a function is for it's a relationship between inputs and output. So for it to be a function, each input may only have one output. Now, but each output, does it have to have just one input? No, not necessarily true, right? For one-to-oneness, then that would be true. Do you guys agree?
Yes.
If it's a one-to-one, then each output must have one input and vice versa for one-to-oneness. But if it's a parabola, like someone of you brought up, I think Edwin. So if you have a y value of 4, you may have 2 x values, and that's still going to be okay. That's a function. So that's why. So that's your own words. The next question says, is a straight line always the quickest way between 2 points? Is a straight line the quickest way between 2 points? Doesn't matter. Doesn't matter. So is a straight line the quickest way between 2 points? Like if I were to run from here to the park, right? I don't want to go like this, right? I want to go a straight line. But, okay? That's what you've been told so far. Alright. Can you help me read? Paul, help me read suppose. Suppose. Read the first 2 lines there. Suppose.
Suppose that a circle of radius A rolls along a horizontal line without slipping. As the circle rolls along the line, point P on the circle traces out a curve called the cycloid. Parametric equations of the cycloids are...
Alright, here we go. Let me give it to you. The parametric equations of cycloids are A some A value times T minus sine of T, and Y equals some A value times 1 minus cosine of T. So we're going to try to graph it out. So let's read this piece in the bottom. If A is negative, Mohini, help me read if A is negative.
If A is negative, we obtain an inverted cycloid that has some remarkable applications in the field of mechanics. 2 of them are called brachistron and tobacone.
Good. So you guys have your calculator on? We are going to just kind of see what this looks like. Calculator, mode, parametric. If you have an older calculator, it just says par. That's perfectly fine. I would like for us to just kind of test out what this looks like on a calculator. We're going to make A 1 just to be simple. So we're going to put in T, take away sine of T. And Y, we are going to enter in 1 minus cosine of T. So that's the X and Y's. I want you to enter that in. Don't go anywhere, just enter that in. T is the same button as like X and theta and so on and so on. Enter that in your calculator. We're going to take this really slow because I need you to be able to use your calculator. Don't do anything yet, just enter it in. For parametric, they're both with respect to time.
I just don't type that.
Why is it T?
Okay. T is time. All right. Hold on. Just enter it in. I need to fix something else as well. So we're going to do one thing at a time. Make sure the plot is unhighlighted. Can you see on your screen the plot and the y equals? Don't go anywhere. Don't go ahead of me. Go back to y equals. Make sure your plot is unhighlighted. Ready? Another thing I want you to change is on the left side of this, do you guys see that you guys have this dashed or dotted line? I want you to change that. I want you to change it to a bar and a circle. Okay. So go all the way to the left. Go left, left, left. Go all the way left. Keep hitting till you go left, and that's linking. Hit enter. I want you to change it to a bar and a circle. Okay, I need you to follow along.
It looks like an idea.
So did it, okay.
I need you guys to follow along so we are on the same page.
Do you want to do the dash?
Just a bar and a circle.
Zero.
Yeah.
There you go. Anyone else need help? All the way left. Enter. Now change it. Go right and left and change it. A bar and a line.
It keeps
There.
going.
Oh, you missed
Go
it. Just like that. Yep. Go find the bar and the circle. There you go. Anyone else need help? Perfect. Let's go to window. Guys, it's your first time, I'm assuming. It's your first time on parametric mode, so make sure you guys follow along one step at a time. Window. Okay. In the window, you're going to have T restriction. You guys see it?
Yeah.
I want you to do T in between 0 and 3 pi, a revolution and a half. All right. Don't go anywhere. Again, don't go ahead of me. I want you to enter that in as we go along. Then there will also be T step. T step, y'all, is the speed. Just leave it alone. Don't change it. If you change it, it's too fast or it's too slow and you don't know how to get it back. So T step is the step of the graph or the speed of the graph. Leave it alone. Now you're going to have X min and Y min. I want you to start at 0. So both X min and Y min. I want it to be 0. You're going to see X max and Y max. I want it to be 10. All right. Enter all of those in. Notice I'm using pi here for T, for the input. That means in mode. Should you be in degrees or radians? Radians. So go back to mode and check it before you hit graph.
Radians?
Yeah, you have to enter in T step. You shouldn't have changed it. So just do pi divided by 36.
You want to
So don't ever change T step. There you go.
Whoa.
All right, hit graph. Once you're in radians. What do you see?
It looks like someone.
What do you have?
Okay, did you guys see the cycloid moving as time goes on? No? Who says no? Now, if you want it to keep going, all you gotta change is the time. Instead of end at 3 pi, you can go 9 pi. Go try it. Put in 9 pi and hit graph again. So your T, put in 9 pi. Hit graph again. Do you see that it keeps going or no? You're stuck still. Are you in radius?
Doesn't make sense.
All right. You guys see that your dot or your cycloid is going with respect to time? Okay. So that's what the calculator does.
Could you use this as a stopwatch?
Could you use it as a stopwatch? When we do application, we could use it to, demonstrate running or cars or whatever. Okay. All right, can you? Edwin! Shh, Help me read this piece.
The red graph is of inverted cycle is the curve of passes and the 2 points.
Ah,
Oh.
all right. So earlier, we talked about how a straight line is the quickest way to get between point A and point B. Which is, for this case, it's proving you wrong. Right? So for this particular case, it's saying my red curve is the quickest curve to get from 2 points. So from now on, what is it? Is the line the quickest way to get between A and B? You're gonna say sometimes, not all the time. Do you guys agree? Yeah.
You said shortest.
Oh, did I say shortest?
Yeah, it says shortest.
Oh, I need to change it to quickest. It's quickest. Okay. I need to change it to quickest. Okay. So the quickest way is not always. Sometimes it's not always. Can you help me read these first two, Claire? Thank you. Paragraph, John, this long paragraph.
The first problem, called a Tran-Bloom problem, began with Galileo's discovery that the time required to complete a full swing of a given pendulum is approximately the same whether it makes a large movement at a high speed or a small movement at a lower speed.
Have you ever seen those in offices? Anybody have one at home? I've always messed around this when I go to like a doctor's office or whatever. And you take one side and you swing and let it go. So this is saying, what is it saying? It's like, even if you pull out far or not very far, what's happening? It ends at the same? Yeah, not funny. Amazing what you can do in physics. Okay. We're not in physics. We are totally background for physics. This is the math for physics. There we go. Parametric equation definition. Let's rock and roll. Parametric equations, guys, it's just another way for us to graph things out. Okay, so suppose that x and y are both given as a function of a third variable called t. And t is actually not called a variable, it's called a perimeter. Okay. So, as you can see, just a preview just a minute ago, you have an x equals and a y equals, and both x and y have a third input of t. If x equals to f of t and y equals to g of t are called parametric equations. Then each unit of t determines your x comma y. Okay. Now some of you like the function notation better. X was given as an f of t, so this is same thing as saying f of t comma g of t, if you like function notations better. So each t, each amount of time determines 1 point for your parametric. Okay. Okay, so next and last definition of this unit is the projectile motion. So projectile motion are those problems that an arrow is going up, or you have some object shooting out somewhere. Those, or you're tossing a ball. Do you guys remember those equations always start out with the negative 16t squared? Right? All of those questions starts out with negative 16t squared in algebra 1 and algebra 2. Yeah, and you never kind of knew, like, why is it always negative? Well, here it is. Up until today, you have always been given those equations. No longer. Now you're going to come up with the equation yourself. So, I know. The more you learn, the less you know. Okay. All projectile motions will have some sort of an object. Okay, is propel upward at an inclination. Let's call it an angle theta. So 30 degrees, 45 degrees, whatever angle it sets, to the horizontal with an initial speed we're going to use v subscript 1. V is really standing for velocity, and then subscript 0 is always representing the initial, the first one, okay? And height from h above the horizontal. It's given. Here we go. Because we're in parametric, you're going to get x equals v subscript 0 times cosine of some angle times t. Then because it's parametric, you would need x and y, so y equals negative 1/2 times g times t squared plus v subscript 0, your initial velocity, times sine of some angle that was given to you, times t, and then plus if you have a starting height. If you're on a cliff 500 feet above ground, then that's where h is. It is obvious what t is. Where t is what, y'all? T is time. You're right. Okay. Now, some of you that are not in physics, you're not going to know g. So we're going to spell out g. G is the constant acceleration due to gravity. And we may use these two units depending on what the height is measured as. So we can use 32 feet per second square if your height is measured in feet, or if it's measured in meters, then we're going to use 9.8 meter per second square. I know your physics teacher uses 10 because it's easier calculation, but we're going to use 9.8, okay, because you're going to have a calculator. All right, we're going to do example 1A and B, and then I'll let you lose. Oh, the negative, it's already in the equation. All right, example 1. Can you help me read the direction, please? Steve.
Graph the curve whose ground metric equations are given and show its orientation. Find the rectangular equation of each curve to verify using the calculator.
Perfect. So in your homework, you will have the instruction that says verify your answer using a calculator. That's an optional choice that you can do. So first is graph it and show the orientation. Then you're going to have to give it back to me as a rectangular equation. So graph it. We are going to make a chart. T is our input. X is the x coordinate of your dot. Y is the coordinate of your y. Then we are just going to get points. That's what these are going. This particular graph has constraint on your time. It wants you to start where? 0. It ends at where? 2. So that means there's 1 second in the middle. So at time 0, where is this object at on the x coordinate? Ken? When time is 0, where is x? Good. When time is 0, where is y, Jeremy?
3.
Perfect. So when you plot your dot, it's just negative 2 comma 3. It's that easy. Well, 1 second later, Haley, where is it on X? Perfect. 1 second later, Thomas, where is it on Y?
5.
Good. So when you plot your dots, negative 1, 5. 2 seconds later, Christina, where is it on X?
0.
2 seconds later, Brandon, where is it on Y?
7.
Beautiful. So 0, comma 7, plot your dots. I need negative 2 on X and 7 on Y, so I need more Y's. Negative 1, negative 2, 1, 2, 3, 4, 5, 6, 7. Okay, your first dot will be at 0. I'm sorry, no, negative 2 comma 3. So negative 2 up 3. That is your first dot. Would you agree that this is your starting dot? Yes, because it says show the orientation of it. That means you're going to have to tell me where it starts, where it ends by using arrows. Negative 1 up 5. 1, 2, 3, 4, 5. 0, 7. Beautiful. There you go. Is this a line, array, or a segment? What's the difference? It's a segment. It starts and it ends, right? So, right. So to show the orientation class, you have to have these arrows. You can put 2, you can put 3, just enough so I know that you're going upward or downward or left or right. Last piece of information is going to find rectangular equation of the curve. Rectangular equation is only for X and Y. There were no T's in there, there are no angles in there. So let's do it. Rectangular. You are given an X equals T minus 2. I would like for you to solve for T for me. How do you solve for T? T equals X plus 2. From here, I would like for you to use this and plug into the Y equals. Your Y equals was giving us 2T plus 3. Every time you see a T, guess what you're substituting in? X plus 2. So Y equals 2 times X plus 2 plus 3. So your final rectangular equation should be 2x plus 7. Again, this curve is a line. Now, I want you to be careful. Your original curve was a segment. This is a line. So you have to restrict the domain. So you may have only a segment. Where should your domain be? Negative 2 all the way to 0. Perfect.
Do we still specify what it was before the restriction? Like, would we have to say it was a line?
No, I just get used to identifying each piece. Because later you're going to be graphing hyperbolas and circles, so might as well just. All right, questions before we go to B for boy? No? Last one for today. X equals t to the half power plus 1. Class, half power is the same as?
Square root.
Square root. Thank you, sir. All right, time x, y, and I'm also going to make another column for a point. So that way I don't have to think about it. This one, time is limited starting at? Perfect. All right. When time is 0, Kayla, where is this object on the x-coordinate?
1.
Beautiful. When time is 0, Ellie, where is this object on the y-coordinate?
0.
Beautiful. So my first dot is 1, 0. When time is 1 second later, okay, where is this object on the x-coordinate, Troy? So remember, the square root, right, of time plus 1. So this is really taking the square root of 100 plus 1. So what would this be? 2. Beautiful. So when time is 1 second, Kenu, where is this object on the y-coordinate?
1.
Beautiful. So my second dot is 2, 0. Be mindful. 2, 1. Thank you. Be mindful, because we're dealing with square root. Instead of picking 2 and 3, what should you pick next? 4. Yeah. Why pick irrational numbers when you can pick rational numbers? Emily, 4 seconds later, where is this object on the x-coordinate? Good. 4 seconds later, Alex N, where is this object of the y-coordinate? 2. Good. So 3, 2. All right. Minimum 3 dots.